Let's continue to use Java to solve Leetcode problems. So for this problem, it is number 9 in Leetcode, palindrome number. So if we read the title, we need to understand what is a palindrome number. So for example, 1 to 1. If we go forward, it is 121, but if we reverse it, it is also 121. So if they are equal, so we're going to call it a palindrome number. So this is the definition of the palindrome number. So if this number is a negative number, definitely it is not a palindrome number. So we're going to return false immediately. So if it is a positive integer, we need to check after reverse, it's going to be a palindrome number. It's going to be a number itself or not. If it is itself, they are equal. So it's going to be true. Otherwise, it's going to be false. There are many methods, but we should avoid to use converting the integer to a string. So we're going to directly use mathematics skills to solve the problem instead of converting the integer to a string and then compare if the two strings are equal. So that's going to be too naive. So we're going to use a normal way, mathematical way to solve the problem. So first of all, we need to check this number. So if this number is less than 0, this means this is going to be a negative integer. So we're going to return a false immediately. Now, we're going to prepare two integers. The first integer is going to be original. Let's just call it original. So the original number is going to be this number x. And the second number, let's call it reversed. So the reversed is going to be a number that is reversed for this number x. So for example, it is 121. After reverse, it's going to be still 121. So for this reverse, it's going to be starting from 0. Now, we're going to start the basic mathematical logic to solve the problem. So while this is a positive integer, x is more than 0, so this means it's going to be a positive integer. Now, we're going to check what's going to be the final result for this reversed number. So it's going to be the formula. Just reverse the times 10. I hope you understand why we're going to use such formula. By using this modular, we're going to find this the last digit of the number. So modular x modular 10. So for example, 121, if it is modular 10, we're going to find this number 1. Yeah. So after that, this number 1 going to times 10, and then this number 1 going to times 100. So it's going to be 121. So this is the basic formula. We need to understand about it. So after we get the last number, so this means we don't need it. So if we don't need it, so this number is going to be divided by 10. So this means first of all, this number is 121. After we get the last number 1, so the number is going to be 12. Yeah. And then we're going to continue to use this formula to get the final result. So let me just use another example. Maybe it is 1, 2, 3. So how did we solve it actually? So from the beginning, this reverse number is 0, right? Now we're going to use this reverse times 10. It is going to be a 0, but we're going to get the last number, x modulo 10, 123 modulo 10, it's going to be 3. Now we have reversed, which is going to be 3. Now we're going to go to the second loop, but this number x is going to be modulo 10, which is going to be 12. Yeah. So this means 3 going to times 10, it's going to be 30, and now we're going to get this number 2, it's going to be 32. And lastly, we're going to have 321. So this is why we're going to use this formula. I hope you basically remember this formula and understand this formula. Yeah. Finally, we just need to check if the original number equal to the reversed number we calculated before. Now let me just run it to check if it works. Now as you can see it works. Now let me just submit it. As you can see, it works and it's pretty fast. So the time complexity is the length of the number. So for example, the length of this number is 3, so the time complexity is 3. So actually, this is a log time complexity. So for example, if this number is 2 to the power of 31, actually the time complexity is the log of this number. It's going to be 31. Yeah. But for here, it is a log 10. So this is a arithmetic algorithm, which is going to be log of this number, log n. Actually, it is the log 10 of this number n. Yeah. So this is going to be the time complexity. Actually, it is the length of the string. It is the length of the string while we're converting this number to a string. I think that's all about it. Thanks for watching. See you